So good afternoon, everyone. We've been discussing about randomized control trials and the reason why surgeons get or many difficulties for participating or for organizing randomized control trials. Actually, many of the studies we would like to see would be designed to examine the effect of an intervention or a treatment, and ideally, a randomized control trial is the best way to do it. But we have said that in many of these cases, we cannot randomly allocate participants to conditions, either because we cannot or it is because we don't want to. I wouldn't be, as Martin said, randomizing my patients to laparoscopic or robotic surgery because I know I will be doing a better robotic surgery or procedure. So for these cases, we should turn to a statistical technique known as propensity score matching for our retrospective studies. I'm going to talk about the propensity score analysis from a surgeon's point of view and for surgeons. So this technique, propensity score matching, is designed to partly correct this limitation of quasi-experimental designs, and it's a statistical method employed in retrospective studies, trying to mitigate biases. The biases we do as selection bias, non-random assessment, etc. So we try and convert a retrospective study in something like a randomized control trial. Because even before a study begins, participants might differ from the others. For example, we will have participants or patients with rectal cancer, but variations like the gender, the neoadjuvant therapy, the tumor's height, the obesity of the patient, all of these may exist before we actually allocate our patients to different groups. So propensity scores come to the rescue here, helping to control these non-group differences and the self-selection bias. So as we said, we perform the propensity score in order to correct these limitations of quasi-experimental designs. So it will identify the matched patient into the control group and will exclude some of the participants for whom there is no match. So now that we understand a little bit the rationale of the propensity score, let's break down the process into the different steps. So the first one and the most important one is to select a set of pretest covariates. And I will explain a little bit more. Then we will do the propensity score, usually by logistic regression. Then the matching procedure. Then we will check with the model adequacy checks, and then we will analyze the treatment effect estimation. So first of all, before diving into any analysis, we must carefully select a set of covariates that we consider potential biases of our study. This step, as I said, is critical because the credibility of our study is going to be based on the selection of the covariates. Let's see this in an illustrative example to understand the application in healthcare research. So, if we consider a study comparing the rate of sphincter-saving surgery between two techniques, laparoscopic and TATME, in a very specific group of patients with obesity diagnosed with mid-low rectal cancer. So the differences here among patients with rectal cancer will significantly influence the outcomes. For example, it won't be the same to have a male or a female patient, the tumor height, the percentage of patients with neoadjuvant chemoradiotherapy, the obesity, etc. All of these will be our covariates and cannot differ between the two groups of the study. However, as we can see here, before the matching process in this study, there is an important difference in these three covariates. So then the second step, the propensity score, will be based on the set of covariates we have selected. The propensity score will be estimated by the program, by the software, often used using logistic regression. So these are our two groups, and here in each row, the propensity scores are similar. In other words, the analysis identified two patients with similar propensity score, so they are matched. The software might choose a participant from the intervention group with a propensity score of, for example, 0.31, and then identify a participant from the control group with a similar propensity score. And then the software will carry on doing this procedure until the maximum number of matched pairs is identified in our database. Therefore, a person with a specific gender, with or without neoadjuvant chemoradiotherapy, and a different tumor's height will be equally likely to be assigned to our intervention condition or to the control condition. So when propensity scores are matched, the design slightly resembles a randomized control trial, because in randomized control trials, this is what we have. Each person is equally likely to be assigned to the intervention group or to the control condition or group. Then, after estimation of this propensity score, the actual matching procedure begins. It can be performed in different ways, but commonly used is the straightforward one-to-one nearest neighbor matching. It means that a single participant is matched to a single untreated participant who has the most similar estimated propensity score. In some cases, we have the ratio matching, like the 2:1 ratio, and can be used as well, which means that two control units can be matched to a single unit in the treatment group. And the most important thing, to ensure robust matches, a caliper is employed as well. It sets your maximum allowable difference between your participants and must be between 0 and 1. So in the example we were using, a nearest neighbor matching was employed, a simple one-to-one matching with a caliper of 0. So as we can see here, we started with 53 and 40 patients in each group, and at the end, a few patients were excluded in both groups in order to find the exact matches. Well, after matching is completed, we should apply a series of model adequacy checks. The objective of this is to check whether the balance of the covariates has truly been achieved during the whole procedure of the matching. Then standardized mean differences, called Cohen's d, are calculated before and after matching to assess the success of our matching procedure. For example, this graph shows a value of Cohen's d of 0 for the 3 of the covariates analyzed, because our caliper was 0. And then in the final step, the treatment effects are estimated in the matched subsample. This involves comparing various statistics between the treatment and the control groups. And ideally, there should be no difference between the 3 covariates included, which is more or less what we will be getting in a randomized control trial. And then after this, we can apply any kind of a statistical model to compare our two matched groups. Student t-test, Mann-Whitney, chi-square, survival analysis with Kaplan-Meier curves, anything you want to compare can be done at the end with the new database and your matched patients. And just wanted to be a little bit practical now and show just a few tips on how to do this on SPSS. This will be our database, and once you have everything completed, you can go to the propensity score matching in data and then propensity score matching. Here, we have to fill in all our details, and here we will be including all the characteristics of our propensity score analysis. So first we have our group indicator. In this case, for example, it would be the approach, TATME or laparoscopic TME. Then we have to include the predictors or the covariates that we have pre-selected before beginning the study, and then the match tolerance. This is the caliper we want to allow. In this case, we chose 0 because we wanted two groups with exactly the same percentage of patients with these characteristics in both groups. And then the case ID will help you to identify your patient, and the rest of the gaps are meant to be the name of the new columns and the new database. For example, here, the one called propensity probability, here the program will give us the propensity score we were talking before. Then the ID match, the program will give the matching patient in the control group. And then the last one is going to be for the name of our new database. So here we can see these two columns we set, the propensity probability score, and then next to it, the program will give us the ID, the patient match to this one because of the propensity score. And a new database will be created at the end of the analysis, including only the patients for whom a match were found. The rest of the patients will not be included in this new database. And from here, you can get your stats for these two now comparable and matched groups. So as take-home messages, I would like to say that propensity score methods offer an approach to deal with this confounding bias in retrospective studies. By balancing covariates, the confounding effect can be minimized or sometimes even entirely removed. This method is increasingly used in retrospective studies, as we have seen in the previous example. Thank you.
Thank you, Patricia. It's something that was quite foreign to me, so I think I understand it a bit better now. Can I take any questions from anyone? Yes.
Thanks very much. Can you maybe tell me a bit about how you, when you're choosing your caliper, how you trade off having a specific value against the number of patients you have, and are there any specific measures? And then kind of as a second separate question, from the journal's perspective, what are your general views on studies like this? And what do you expect from authors in terms of writing about the limitations of these methods and potentially unmeasured confounders that obviously you don't know what's going on?
So the caliper you're choosing is going to depend on the covariates you are including, I guess, and I'm sure Jonathan has something else to say. But for example, in this case, if we are talking about patients with or without neoadjuvant therapy, caliper has to be 0. I want exactly the same number of patients. I cannot have 60% versus 30 because then results are going to be completely different. But I guess it's going to be depending on your covariates. If age is a covariate, maybe you can allow a higher difference because you don't mind to have patients with 50 versus 55 years old in your study. But it's going to depend on this, and the covariates, the selection of these covariates is the most important thing. If I will be reviewing a paper with a propensity score, the first thing I have to check is if I think that the authors have included the really important covariates that are going to be confounding or bias in their study. If they are including everything, even if the sample size is small, but it's because they have lost lots of patients because of this, then the study makes more sense. It is better to have less patients than to have maybe only 1 or 2 covariates but are missing lots of confounders for the study.
Okay, thank you. Arvid?
Has there been any discussion when propensity score matched studies shouldn't be used? In one sense, I feel that the matched database reassembles the per protocol analysis. The ones who fall out could be interesting in a study, in a sense. Is there any discussion?
No, they definitely can be a very interesting group of a study, but you also have the option to do the 2-to-1. So if your 2 groups are very different in sample size, you can take 2 from one group and 1 from the other. That's a way to do not miss a lot of patients. So that's also a good idea, but the difference is not too high then. Maybe in this example, for example, you will be missing maybe patients with without neoadjuvant therapy from one of the groups because you don't have a match in the other one. So it's interesting to see them. That's why we always, in propensity score analysis, we have to report also the results for before the matching. So you will be given tables before and after matching, at least as supplementary material.
Patricia, is there a critical threshold for a number of the patients that you lose? I think you've lost about a third in your TATME paper. So if you lose 90%, does that suggest that really your 2 groups are just beyond compare?
Have anything to say, Jonathan?
Well, I think I can use this, Mike. So the proportion you lose, in one sense, doesn't matter. If you've got a good match, then that's okay. The issue, I think, which previous questioner was alluding to, is that who have you analysed and who can you make inference about or comment about? And it's the match group, not the big group that you started off with. So what the reduction does suggest is probably either there's not very many with the newer thing, the more unusual thing that's just occurred, not many cases, or may also suggest that they are a very smaller subset of the bigger population. So in one sense, the approach tries to get you somewhat like an RCT with a propensity score. If it works well, it gets you a comparable pair of groups. But by doing that, it has to strip out all those who aren't represented in both groups, if that makes sense. The bigger the sample you start off with, the better the match you can get. But it's still a match, so you've restricted that original population quite a bit. So it's kind of, you have to be conscious of that in terms of the interpretation of the study.
And are you better off having more matching criteria?
Yes and no. The more you match, the more restrictive your population's going to be. But if that's rich matching, then that could be very good. If that's helping you as a surgeon to narrow down to the population that you're really uncertain about, then that's a good thing. And if you can if you can measure those things, I think that's the challenge. Can you measure them? Were they measured in a particular study? The bits of information we really want to know. Often unfortunately, it's a fairly basic, easy to measure things that are routinely collected that are available for the propensity score. And some of those are useful. I'm not saying they're not useful, it's just they're not the complete picture in terms of patient stratification. So you get age, you get SA criteria, you get their basic diagnosis, but will you get all the other little bits of information you'd ideally want to know?
Yeah, I have a comment related to that and a question. The comment was, I remember seeing I've never done a propensity matched analysis, although I've been interested in them. What I'm hearing is that from a statistical purist point of view, it sounds like it's somewhere between, in methodological, the triangle, somewhere between a cohort study and an RCT. Is that a fair assessment?
If it's done well for the group that you're comparing, it's attractive because it gets you a more unbiased comparison. If the matching process has gone well, that's the caveat. But if it does, then yes, it's certainly better than just blindly taking everyone in one group and everyone in the other group and expecting them to be the same. Because almost always that's not true, because the people who get robotic surgery will be those most conducive to it, or those that got laparoscopic are not the most difficult cases initially. They're the kind of more straightforward cases to learn the procedure, and when you're looking at a retrospective institutional or personal learning, that's a natural way that you would approach adopting something new.
Okay, Dimitri?
Yeah, I just wondered, so when you're doing your matching, there are potentially multiple cases that could, so controls, if you like, that could match with a particular case. And presumably your software is somehow randomly choosing one of those to match. So if you reran your analysis, is there a potential that your result can actually change depending on like what patients are being matched, and potentially change quite a lot? Because there's some random element there. How do we take that?
Shall I answer on that one? So it's unlikely to change much. I hesitate because there may be an unusual circumstance where an algorithm might default to a random sample, but that implies that you would have more than one option based on all the criteria you put in. I think certainly most of the propensity score studies I've seen, and the match studies in particular, they often end up with numbers of not too dissimilar to an RCT, but obviously the process to achieve it has been quite different. But 100 or 500, which is a big study. It's not small in surgery. That's a good size study, but it's not humongous. And for each of them, a lot of them, there's often not 2 or 3 or 5 or 10 matches available. There's often only one. And what you get, which is why it's good to show the population before and after, and also the distribution of the propensity scores is nice to see, because what you can often see is the tail where there was no match. It's interesting to know how many were there that could have been in for robotic surgery, but I couldn't find a match. That's probably less likely, but it's the other way around. There's loads of lap cases which I can't find any match for them in the robotic surgery group.
Okay, Amira?
My question, or rather my comment, is not about propensity matching. I actually have 2 points to raise, and it's an open invitation for any of the speakers to contribute, because we are talking about top tips in publishing. And there has been a lot of mention of transparency about missing values, transparency about confounders. I don't know how often you see this as reviewers and editors. Transparency about the nature of the study. Someone submits an RCT or meta-analysis systematic review because they know they're well sought after by journals. But when you read it, it's not a randomized control trial. It's not a bad piece of science, but it does not deliver as a randomized control trial. So what are your experiences and your tips for authors on transparency in submitting that kind of research? That's my first point.
Okay, let's deal with that one. So I suppose there's two scenarios. One is they've made a mistake. The second is they're trying to pull the wool over our eyes. And I think in either case, I think the BJS approach is, if this is good science, if it's well written, we will work with the author to try and deliver that as a published article. Now, if we go back to the author and say, this is not a randomized study, this is a retrospective cohort study, can we sort of publish it as such? And they say no, then clearly that's the end of that relationship. But I think, if it's a genuine sort of misunderstanding, then that's fine. One would hope that the boundaries are quite clear when we're determining between the 3 or 4 main study types. Is that fair, Martin?
Yeah, I completely agree with what you said with that, Peter. The other thing I was just going to sort of articulate is that when you come to identifying the limitations in your work in a discussion, I'm often asked, should I be open and honest about it? And I have to say my advice to you is yes. You as an author know your limitations better than anyone who's going to review it. If you don't include it, it's likely that good peer reviewers are going to pick up on that and then highlight it as a flaw. Whereas if you've included that in your discussion from the outset, actually you can get a more sympathetic eye to it. Nobody has ever done the perfect study, and I doubt anyone ever will do the perfect study. So, really the message is transparency and honesty is absolutely the best approach throughout when you write up your work.
Reviewer, I just thought, let's change the title and then we'll get talking. I think the second question for us as surgeons, we're quite intimidated by all this statistics and propensity matching. So will artificial intelligence make our life easier? What is the role of modern technology in publishing and RCTs?
The short answer is yes, I'm sure it will make our lives easier. But it's probably, in my eyes, it's like all things with AI. It's about understanding what the AI has done and us as humans being able to understand what it's done and critique and check that it's been done appropriately. From a statistical side, Jonathan?
I mean, it will change. It's really hard to predict. I certainly, doing a propensity score study is a lot easier than when I started doing research. I was working with some people who told me what it was like 10 years earlier. And they used to say, well, I ran one model overnight. I'd set it up, run overnight, and then come back and get the result of one model, which is unthinkable now because it's a decent computer is a matter of seconds for even very complicated models. So, and that has made life a lot easier. It's created problems as well, and I suspect AI might be similar. It will make a lot of things easier, but I think it will make us run risks that we don't appreciate at the moment of going very far down the line in the wrong direction because it will just automate every step for us. So I think it's going to be a good tool, but also there needs to be a bit of care.
Yeah, so I think we're all hopeful that we don't lose our jobs, and that the need for human checks and balances will still exist within the context of ever expanding AI.
Patricia, as a surgeon, would you always take gender as covariate?
No, it depends on the disease or the procedure or whatever we are analyzing. In this case, for rectal cancer, it's an essential. You have to, I'm sorry, but you have to choose gender. Otherwise, it's a huge bias. But it's going to depend on the study, definitely. Yeah, it's the same with BMI or DH or anything else. It's as I said, and I'm just going to say something else. I need to. AI may help at some point, but in things like this, here, for example, in propensity score analysis, the most important thing is to choose wisely your covariates. And this is something that is going to depend on us. I think AI can help. Probably if you ask ChatGPT, what would you choose for this study? He will give you exactly the same, but still you have to think, you have to discuss with someone else and with the research team, what are the confounder factors we are expecting? And this is something we have to do. And then we can ask AI to run the statistical study, or you can put a statistician on your life, which is easier. But these first steps, I think, should be done by us, by surgeons.
Yeah. I think just to pick up on the comment about gender, which is that I think one thing as we look forward in surgical research is to get better at collecting what in the UK we would call data on protected characteristics like ethnicity, race, sexual orientation, socioeconomic status, and so on, because very few surgical papers at the moment actually present that data for their patient groups. So it's very difficult to then interpret how generalizable that data is to the patients we're actually looking after. So not directly applicable to the presentation, but I think just something that as surgical researchers to think about in the future.
Comment on this point or the extra?
Yeah. Do you want to give us your statistical pearls for propensity
I thought that was a good response in terms of biological sex, or if you're using the term gender. It would very much depend on the study that you've done and the context and what the questions you're asking. Age, I think, almost always is a useful, at least statistically, in terms of if you're using a method like propensity score that is adjusting for it. There are some studies I've come across where age doesn't matter. And that's only because the patients have been so stratified in advance that basically those that got in are a very narrow age group. But in most of the studies you'd see in the BJS, I think age is quite a useful explanatory variable as statisticians would describe it, and so you'd often want to take that into account, or at least see that what impact does it have. So I'm just going to give some top tips about propensity score based studies. So I'm going to broaden out slightly from matching, and so one of my points that I would raise as a statistical consultant reviewing these papers is be clear about the propensity score, what it was developed and how it was used, and each use has a different implication. I mentioned earlier that there isn't just matching, although that is a very common use of propensity scores. There's adjustment or weighting approaches that try and use propensity score in a slightly different way. And just be clear about what you've done. I did review a propensity score matching study recently that didn't actually tell us how the propensity score model was produced. Now, almost always it's logistic regression, but it's your onus to write that and explain what you've done, even if it's what most people do or you think it's so obvious, because it's not actually, strictly speaking, necessary to have to do that. And it's important to be clear, for sake of transparency, what you have done. And each of these approaches, anyway, whatever you do affect your interpretation. And then we need to think about propensity score of what? It's usually about the treatment, and therefore we need to think about it in that context. And a propensity score study, like any research, can only be as good as the data that you've got. And the question then is, whose data did you start off with in a propensity score study? Who do you have? How did you estimate your propensity? And what comparison do you end up with? And so it's important that we kind of discuss whether, and this was raised in discussion, can the propensity score credibly account for the key treatment decision factors? What's included, what's missing, and what types of patients? At the end, when you're coming to a conclusion, if you've only included a very narrow subset of patients for a certain condition, operated in a certain way, you shouldn't then make statements, oh, well, this is definitely the best operation for all hepatobiliary patients with this problem. You've got to focus your discussion, your comments on those that you've analysed. What can the analysis bear? and then how does it fit with the original research question that you have or others would have, and discuss it in that light.